Hello everyone and a very warm welcome. So this is 30 days, 30 questions J Advanced series, and let us see what is the question for today. So the question goes like this. Question hai comment upon the nature of roots. Comment upon the nature of roots of the quadratic equation. Comment upon the nature of roots of the quadratic equation. अब इक्वेशन क्या लिखी है? इक्वेशन है x square plus 2x is equals to k plus integral 0 to 1 modulus of t plus k dt. Depending on the value of k belongs to R. Fine. So depending on the value of k belongs to R, we need to find out what kind of roots does this equation will have. अभी nature of roots का मतलब ये है कि you just need to identify the discriminant of this quadratic and check whether it is negative, positive, zero, what kind of answer you are getting for D. Okay, that will help us in identifying the nature of roots. But again, if you observe the question carefully, for calculating the value of D, I need to come across this integral. Right? So I actually have to find out what is the value of this integral so that I can easily find out the discriminant D. तो हमें इस integral के लिए question solve करना है. Then we have to move further and solve it for the quadratic वाला concept as well. तो चलिए proceed करेंगे. First of all, I'm just concentrating on the integral 0 to 1 modulus of t plus k dt. सिर्फ इसी पे concentrate करते हैं. सॉल्व करने के लिए क्या करोगे? देखो k के लिए इन्होंने कुछ भी कंडीशन नहीं दिया है. इन्होंने सिर्फ इतना कहा है कि k बिलोंग्स टू ऑल रियल, कि आपके पास एनी रियल वैल्यू ले सकता है, राइट? बट यहाँ पे मॉड्यूलस भी है, एंड वी नो दैट इफ मॉड्यूलस है एंड इन केस द फंक्शन इज चेंजिंग इट्स रूल इन बिटवीन 0 to 1, देन आई हैव टू स्प्लिट द लिमिट अकॉर्डिंग टू प्रॉपर्टी नंबर 3 ऑफ डेफिनेट इंटीग्रेशन, राइट? तो अब जरा चेक करते हैं कि हम इसमें k पर डिपेंड करते हुए किस तरह से डेफिनेट इंटीग्रल को हैंडल करेंगे. 0 to 1. So in the first case, I'm just assuming that let k be positive or 0 also. Suppose k positive or 0 hai. If k is positive and 0, then in this interval 0 to 1, t is also positive or 0. Overall, the quantity within the modulus is positive only, right? So in the interval 0 to 1, I can say that t plus k is going to be positive. Agar ye positive hai, so you can write integral 0 to 1 modulus of t plus k dt as simply integral 0 to 1 t plus k dt. That means I just removed that modulus sign, right? t का integral क्या आएगा? t square by 2 और k का integral आएगा kt. Put the limits 0 to 1. What we are getting is 1 by 2 and plus k. That's it. This is what we are getting as the integral value when k is greater than 0. Now we will come to another value, another case. अब हम k को नेगेटिव ले लेते हैं. k को नेगेटिव लेने का मतलब क्या है? नेगेटिव में तो आपके पास 0 से लेकर 1, यानी देखो बेसिकली इस मॉड्यूलस का जो क्रिटिकल पॉइंट है ना, दैट इज टर्निंग आउट टू बी माइनस k. So I just want to know whether minus k is belonging to 0 to 1 or not, right? So I'm taking first of all k outside this interval. So basically the critical point is lying outside the interval, means either k has to be positive, which case we have already taken. So the second case which I'm taking is minus k greater than 1, implies k less than minus 1. ये सब हमने यहाँ पे रफ में चेक किया. And then I'm taking the second case, कि अभी second case में मैं k को less than minus 1 ले लेती हूँ. This is the second case we are going to talk about. आप equality भी ले सकते हो यहाँ पे, not an issue. अच्छा, k less than minus 1 होगा तो क्या होगा? Now you can see 0 to 1 modulus of t plus k dt. So just observe that t is only having the value which is a fraction 0 to 1, while k has a value which is less than minus 1. So can I say that the sum of these two is definitely going to be negative? It will become negative. Why is it negative? Because k का magnitude t से ज़्यादा है and it has a negative value. So my answer for this integral, first of all, we will write it as minus of t plus k dt, and then we are going to integrate it. कैसे integrate करोगे? This will become minus t square by 2 minus kt. The limit is from 0 to 1. Keeping the upper limit 1 will give me the answer minus 1 by 2 minus k. Lower limit it will be 0. So here is the value of the integral when you are taking k less than minus 1. अब एक ही case बचता है. In that case says that you have to take k from open interval minus 1 to 0. If you are taking k in this interval, then definitely you cannot integrate the function as a whole. क्यों नहीं integrate कर पाएंगे? Because you can see that t plus k, जहाँ t की value 0 से 1 के बीच में fraction कुछ है, some of the portion में it is going to take positive value, some portion में it will take negative value. Well, we will have to split the limit at its critical point. Critical point कितना आ रहा है? Minus k. और माइनस के इस 0 to 1 को डेफिनेटली बिलोंग कर रहा है, इसलिए आप डायरेक्ट इंटीग्रेशन 0 to 1 में नहीं कर सकते. यू विल हैव टू यूज प्रॉपर्टी 3 एंड स्प्लिट द लिमिट एट द पॉइंट वेयर द फंक्शन चेंजेस इट्स रूल. अब इंस्टेड ऑफ यूजिंग दिस माइनस के ना, व्हाट आई एम गोइंग टू डू, जस्ट टू मेक द क्वेश्चन लुक कंफर्टेबल, आई विल अज्यूम दैट k इज इक्वल्स टू सम माइनस, क्या ले ले, माइनस अल्फा ले ले. आई एम गोइंग टू टेक k इज इक्वल्स टू समथिंग लाइक माइनस अल्फा. Now I can say alpha will belong to open 0 to 1. And my question will look like integral 0 to 1 modulus of t minus alpha dt. Further, you can easily write it as 0 to alpha. And then we have alpha to 1. 0 to alpha means now you're taking the value of t somewhere between 0 to alpha. So t minus alpha to negative हो ही जाएगा. Negative है यानी you can write it as alpha minus t and integrate it. Similarly, alpha to 1, if you take t alpha to 1, t is greater than alpha now, so this will become t minus alpha dt. Fine. Abhi kya kare? Integrate it. Integrating it gives me alpha t minus t square by 2. Putting the limit 0 to alpha. Then we have t square by 2 minus alpha t, alpha to 1. Putting the upper limit gives me the value as alpha square minus alpha square by 2. Lower limit पे everything is 0. यहाँ upper limit पे it becomes 1 by 2 minus alpha, while the lower limit gives me minus alpha square by 2 and plus alpha square. So as you can see, all alpha square when I club together, I'm getting only alpha square. Then we have minus alpha plus 1 by 2. But what is alpha? Alpha is actually minus k. So you better replace it because my answer should be in terms of k. So this is the value of integral when you take k between minus 1 to 0. Correct? अब क्या करें, अब integral value एक साथ लिख लेते हैं. Then we will go for the discriminant of quadratic. So what exactly is the integral value that we are getting for 0 to 1 modulus of t plus k? So well, what we did in this question, we just identified the critical point is lying in this interval or outside this interval. Outside this interval था तो we need not to split the limit. हमने डायरेक्ट मॉड्यूलस साइन हटाया एंड इंटीग्रेट किया. बट इफ द क्रिटिकल पॉइंट इज लाइंग इन द इंटरवल, देन यू डेफिनेटली हैव टू स्प्लिट द लिमिट एट द पॉइंट व्हिच इज द क्रिटिकल पॉइंट ऑफ मॉड्यूलस. सो दैट इज व्हाट वी हैव डन. एंड फाइनली वी आर गेटिंग 3 आंसर्स. द 3 branches we are getting here. The first branch says that answer will be k plus half when k is greater than equal to 0. When you have k belonging to open minus 1 to 0, then your answer is k square plus k plus 1 by 2. And when you have k less than equals to minus 1, the answer turns out to be, हमने क्या आंसर निकाला था, I think minus k minus 1 by 2, right? एक बार फिर भी verification हम कर लेते हैं so that calculation error हमारा ना जाए. Yes, so this is the value that we got. Okay, all the 3 values are ready now. So let us go to the discriminant of the quadratic. What is the quadratic? Let's write first. So the quadratic is actually x square plus 2x minus k minus integral 0 to 1 modulus of t plus k dt equals to 0. We'll be finding out the discriminant. So let us start with the first case when you take k greater than equal to 0. The discriminant in this case means your quadratic will look like x square plus 2x minus k minus, what should I write here? K plus 1 by 2 equals to 0. K and k got added and we are getting 2k over here. ठीक है, चेक करते हैं जरा हमारे पास क्या साइन आएगा अब एक्सप्रेशन का. डिस्क्रिमिनेंट आई स्टार्टेड कैलकुलेटिंग. तो डिस्क्रिमिनेंट टर्न्स आउट टू बी b square minus 4ac, right? 4ac. This is what we are getting. But k is positive means this quantity is positive only. Overall, the sign of t turns out to be greater than 0. So that means if you have k greater than equals to 0, the roots of the quadratic are going to be real. The roots of the equation are going to be real. We will be getting roots as real. And what can we say about the distinct? Will they be distinct? So yes, because k is greater than equal to 0, overall value I'm just getting greater than 0. तो यहाँ पे तो real distinct answer लिख सकते हैं. यहाँ पे in this case you are getting real and distinct roots of the equation, right? अभी second case solve करेंगे when we will take k less than equals to -1. यानी अब आपका quadratic नजर आएगा x square plus 2x minus k. Now put the value of this integral which will be minus of minus k minus half. यानी ultimately ये equation बनता है. And regarding the discriminant of this equation, what we are getting is b square minus 4ac. यानी ये तो 2 आ गया. Greater than 0 means यहाँ पर भी roots कैसे आ रहे हैं? Real and distinct as well. यहाँ पर भी roots real and distinct आ जाएंगे. Correct? चलिए, let us move on to the third case. अभी हमारा third case क्या है? In the third case, I am taking k between -1 to 0, and that is why the equation will take the form x square plus 2x minus k. अब क्या लिखना है? अब हमें चेक करना पड़ेगा हमारा फंक्शन क्या आया था? k square plus k plus 1. This needs to be subtracted. So k square plus k plus 1 by 2 or 1. So I think 1 by 2 हमें मिला था. फिर भी एक बार वेरिफिकेशन करके ही लिखेंगे plus 1 by 2. This is equals to 0. I can cancel this k. No, I cannot cancel it. I am getting x square plus 2x minus of k square minus of 2k minus 1 by 2 equals to 0. Let's write down its discriminant. So discriminant d will be b square minus 4ac. So minus 4ac means plus हो जाएगा ये. This will become k square plus 2k plus 1 by 2. Let us check what we are getting. So 4 I have taken common. This is k square plus 2k and plus 3 by 2. Correct? This is how we can write it. Or I can write it as k plus 1 ka whole square and plus 1 by 2. You can see that because k plus 1 is positive, k plus 1 is positive. That is why, that is the reason I can write this quantity as greater than 0. It won't take the value equal to 0. It will always be greater than 0. अगर ये greater than 0 है तो again इस situation में हमारे पास कैसे आ गए? The roots of the quadratic are real and distinct. यानी basically whatever k you are taking, any real k के लिए, the quadratic that we were handling has real and distinct roots. You see such a beautiful combination of the concept from the quadratic and the concept from definite integration. So here we use property of definite integration to solve the integral, and after that we were able to identify the discriminant ka sign for the quadratic, and hence we were able to answer the question. Hope you enjoyed today's question. Hope you are enjoying this series as well. So please do not forget to hit the like button and share it with your friends, family members and your peers. See you in the next video. Till then, take care and bye-bye.